Today is the first step in constructing a artificial neural network, and it's going to be a very, very interesting one for the starters. And you see, you will really be able to understand how a neural network learns artificially. So what is experience for the humans is learning through data for the computers. Let's get into it. If you see to the left, we have a biological neural network. If you see to the right, we have an artificial neural network. So the data will be processed from one layer to the other layer. We have an input layer, if you see this one, and then all the way we'll get the output information. If you see here, we have this input layer. This is the first layer. And then from input layer, the data will be processed. And then you will go here. This will be our output. We'll get results here. Now in today's class, you'll be able to follow how data will be processed through the neural network. Here, this is human brain. This is automatic, God-given power. But now artificially, we'll see how this kind of a neural network will learn. So now we have an input layer. We have two hidden layers. If you count the three inputs, we have two outputs. Here we have 4 neurons. Here we have 4 neurons. Okay. Here in output, we have 2 neurons. So these are the neurons and they're connected here. Remember, we have mainly 4 types of data. If you use traditional machine learning, you will be able to process mostly tabular data, Excel, CSV data. But when it comes to image, when it comes to image, when it comes to text, when it comes to videos, that capability is very, very limited. It's almost nothing. We have some algorithms, but that fails. Whenever you have large amount of data also, you have to use a neural network like this. Okay. However, in this class, we'll have a very, very simple neural network. If you see here, I will start with one neuron here, and this will be my input here, and I will have a tabular data. We'll start with tabular data, and then slowly we'll see how we'll be able to process image data, audio data, text data. If you are using ChatGPT is processing text data. So you need not worry now. So this will be our data here. Okay. Suppose this is my half yearly exam marks. These are half yearly marks. And this is my half yearly marks. And this is my final exam score. So what we want our neural network to learn here is how the neural network will learn the final exam marks, final exam, you can say, final exam. As I already mentioned you, as humans, we have our brain and we have our neural network, which learns from experience. Now, because there is no experience for the neural network, we'll train taking data. Data is equivalent to experience to humans. Now, this is the data. So what exactly we want to predict here? We have some students' data, some students who appear both the exams, that is available. That means there is a guy, suppose A, and then B, C, D, these are the 4 students, and they appeared half yearly exam and final exam for any class. And those who scored these half yearly marks, for them, the final exam scores are available. Now, what is that we want to do here? We want that our neural network will predict for a new student. Suppose a new student appears the exam, and we know the half yearly mark. Question is, now consider a new student. New students appear exam. What we exactly want here is the new student appear the final test. The new student already appeared half yearly exam, and just today he appeared the final exam as well. And we know the half yearly mark here 6. We know this. And today only he appeared the final exam. But the result will come after 45 days to after 45 days or 2 months. Okay. So this guy can't wait. This guy can't wait. So he wants to have a first hand information. He wants to have some information so that he can plan further. So what he will do is he will take the help of a neural network. Okay. So this is a very, very simple neural network. I've taken one neuron here in the output layer, one neuron. This is input. So what will happen is when the data will flow, I mean, this is the way from left to right. Now, what will happen is we'll train this neural network. Okay, let me enclose this. First of all, we'll train this neural network, and finally, this will be trained. This is a very, very small, simple neural network we've started. Okay, in course of time, you will learn more. Now, what will happen, because there is only one connection, I'll take you through different kind of neural networks once this is over. Now, we have only one. Now, what I will do is we'll connect. So, what the neural network will do? Neural network will learn. How neural network will learn? From this data. Because this is the data, we'll give to the neural network and say, learn. How it will learn? It's a mathematical way. Okay, I'll explain you what it will do. Listen carefully. This is also true in machine learning. Okay, those who are doing linear regression, similar kind of a thing. Now, let me write here. What the neural network will do, it will try to multiply this number 1. It will try to multiply number 1 with some number, and it will check whether it's getting 3 or not. And this is called the weight connection. Okay, now it will multiply a number, remember the same number. It will try to multiply 4 with the same number. It will see if it can get a number like 12.1 or not. Exactly, it's not possible. With some loss only we'll be able to do, because whatever way we want, the real world data is not the same way, right? So it could have been 412, that would have been better. Like if you multiply 1 with 3, you get 3. If you multiply 4 with 3, you will get 12, right? But it's 12.1. This is the real world data. 5, if you multiply with 3, then you should get 15, but we have 14.9. That's okay. Now, if you multiply 8 with some number, you should get 24.3. It will try to do that. And we are sure that there is no such number, right? Mathematically, if you write A, B, C, D, you can't solve all this. Even if you solve, it's not going to be useful. We want to see the pattern. So if you want to see the pattern here, you are after one such number, one such magic number. Now we have 4 data. In the table, we have 4 rows of data. It will be 40,000, 4 lakhs. And remember, neural network is not meant for this kind of a task where we have a 4-row data. We don't want to kill an ant with an atom bomb. Okay. So a simple linear regression will work here. However, we're learning. Okay. So if you have a large amount of data, definitely you will prefer a neural network, and then deep learning, more layers. We'll go to that. Now we are after that magic number here. Not only this one, remember, very important, another bias. Mathematically, I will explain this one. Another bias also you can add from outside. Those who know equation of a straight line, y is equal to a plus bx, mx plus c we say. And in linear regression machine learning, we write a plus bx. Now, if you see this equation, here y is a multiple of x, that we see here. On the top of that, there is also 1. There is a geometrical interpretation mathematically. We'll go to that later. But remember, a bias is also allowed. So what will happen when bias is allowed? We'll see we're allowed to add some number also. Not only will multiply. Okay. Ideally, if you multiply, if you get it, that's fine. You do that. You take that magic number. Okay. No problem. But then we have an option here also. We can add something like, suppose I will write it 2.5 or 3.5, or suppose 3 only I will write. Suppose I'll write 3 here, and I will add a number here. Suppose I will not add anything, right? That's fine. But it should be same. That's the problem. If I don't add any number, how you will get here? You will get a minus number, right? So you don't mind adding 1, but these are not the real one. The real ones I will show you. That's where the machine will learn. So here, deep learning or machine learning, what is deep learning here? Deep learning means it will try to find the best combination. It will try to find the best combination of this weight and this bias. Okay. So these are the two things you can say. Here, I've taken point one as a sample. If you have 40,000 data, you will never try, right? So never mind. For my fruitless exercise, see 3 equal. If mathematically you will get a number, that magic number, when you multiply with this, I mean, 4 rows of data we have, right? So that will write here. And then here I've written point one I will write here. So now you imagine Chart GPT. Chart GPT is kind of this thing. Okay. If this is an ant, Chart GPT is like an elephant. Okay. So if you think about this, this is a pre-trained model. What we have done, this is not, training is not over. Okay. Training is not over. Suppose we think that with these weights and biases, the loss is very small. We have a very minimum loss. And how to calculate loss? We'll do that later. Not now. No worries. We'll have so many classes. Now, with a small loss, what we want is we want the connection from here to here. If you are giving the input, okay, like for the new guy, we'll put 6 here, and the answer you collect here. 6 multiplied by 3 plus 0.1. So what is my answer? 6 multiplied by 3. 6 multiplied by 3 plus 0.1. That is my answer. We'll do the coding also today. So 6 multiplied by 3 plus 0.1, that is my answer. Okay. So that is 18.1. So 18.1. So in a world where the marks are given this way, in decimal also, in that world, in schools we don't give, but in engineering colleges we have, right? We get in points. You just imagine I've taken half yearly, full yearly, final exam as an example. So 18.1 is our prediction. Now, when the neural network will predict 18.1 for 6, it should work because it captured the pattern here. It captured the pattern here. When it captured the pattern, seeing the data, whatever data we provided, that means, remember, this is very important. Data, according to data, if you have toxic data, then your result will be that way. So if you have good data, you have a large amount of data, it will learn properly. So ultimately, whatever there in data, it will learn. And if you see mathematically, it's nothing more than mathematics. We can do it manually also. But 4 rows, if you have 4 rows, we can do this, we can learn. But suppose you have 40,000 rows, 4 lakhs, then we can do manually, right? Even if we do manually, it will take a lot of time, right? Even with a single neuron, see, this is my neuron, okay? This is input. So with a single neuron, I'm able to train 40 lakhs data. Same method. So ultimately, what is a pre-trained model? GPT, okay? GPT. It's a very sophisticated one. I'm not going to that, but remember, pre-trained transformer. Again, I'm not talking about transformer now. Now, here pre-trained. What is pre-trained? Now we trained this neural network. Now what we can do is we will sell this neural network. We'll give this neural network to someone. We'll give this neural network to others. So what they will do is they will use the neural network as a formula. If we deploy this neural network in AWS or Microsoft Azure or in any platform, okay? I'm writing the main ones, GCP. Then what will happen? Whenever you write a number, you will get a number here. That's all. That will be our output. And that will be the prediction. Okay. So behind this one, behind all the training, it's not that we'll show this data, it will see, it will learn. How it can learn? There is no reasoning here. There is no consciousness here like humans. The neural network can think. Okay. Even when we talk about Chat GPT, many people think, even my relatives, what they think is they use it to generate a poem, to generate a blog whenever they need. So they are feeling that Chat GPT knows whatever it gives. No. Chat GPT, when we say, it's a stochastic parrot, it's a digital brain, but it has no consciousness, no reasoning. It can't reason. Okay. So that's why we say black box. Anyway, we'll go to that level because ultimately our aim is to go to generative AI, right? Yeah, we'll do that. Coming back to this one, this is a pre-trained model. This is a pre-trained model. When I say this is already trained, okay? This is not, but for example, suppose 0.3 and 0.1 will work because you have to fix one such connection here and one such connection here. Now, someone might give me a number like 3.1 here and minus 0.1 or 0.05 or 0.2. So which one I will choose? My question is, if someone says, no, I think 3.1 and 0.05 will work better than this one. So how can we check? That's why we have to find the loss. We'll go to loss, okay? And we'll see what is the loss in both the cases, and we'll definitely accept those weights and biases where our loss is minimum, okay? Now we'll use TensorFlow for this, okay? For the classes, for some time, we'll use TensorFlow. And suppose you are using any kind of tool, no worries, we'll use Google Colab. And slowly we'll be able to know what is the usefulness of Google Colab and all that. We'll see that, we'll get the minimum loss, okay? We'll go to that. But before going to that, let me take you through another example, okay? Let me take you through another example. Then we'll go to the coding also. Now, suppose instead of that example, whatever I've given, I will have another example here. What I want is, I want now this kind of a thing, okay? So here, if you see, I have two input, not one input, and I have one output. So those who have already studied machine learning, they must have some idea. If you've never studied machine learning, no worries. I don't want to connect machine learning here. And in course of time, definitely while learning this, you learn a bit of machine learning also. So the concept is same. In machine learning, we use different methods, but here in deep learning, we try to mimic our human brain. This is a class where they conduct 2 unit tests, okay? And the final score is also available because this is data. Suppose this data is the old data. Old data, when I say, suppose these are the guys who we joined in 2021 and passed around in. Suppose these are the data where they joined in 2022, passed in 2023. This is sample, means all we know. Not only these two, this one also we know. We know the final mark. Final mark was here 55 for this guy. And for this guy, it was, I mean, you can write anything, okay? 52. And this one is 45. This one is 88. So we know all three. When we say sample, we know all three. Now consider a new guy. This guy joined the course in 2023 and the exam is in January. He appeared the exam also, 2024, January. It was on January, suppose 3rd January, and he appeared the exam. Now this guy knows already these two and will ask these two. He will say, for suppose for this guy, 10 and 50 we know. For this guy, we know 20 and 70. For this guy, we know 30 and 80. For this guy, we know 40 and 90, right? Similar to this, for this guy, again, I'll take you through how to deploy a model. Everything we'll do. End-to-end project, okay? Just be with me. Now, what will happen? I'll show you how it works. You have to, there will be interface here. This is your front end, okay? Here, there will be a box where you need to put first unit test. Suppose this guy, first unit test score is whatever, like it could be suppose 25, and second unit test is 75. And this guy says, predict for me. Okay, I'm here. So what I will do is, I will use this neural network. I will use this neural network. In this neural network, if you see what I have 2 boxes. Okay, this is a browser. This is a browser. Okay, here I can put the values and here I will get my answer. I will show you this kind of a browser. Okay, shortly. So here we have to put 25. Here we have to put 75, and we'll click here, enter. There will be a button here. This is a button here. Enter. You enter it or you press it. Okay, whatever you say. And finally, boom, you will get the answer. Okay, that answer will be whatever. I mean, we don't know now. Okay, so what this one will use, this browser. Okay, again, we have a concept of request and response. I'm not going to that now. When we request, okay, this browser will give the response. That's a part of deployment. Okay, we'll go to that later. Now, will get answer here. How it will give the answer? Because we have given our trained neural network. So now what is our trained neural network? We have given, see here, I'll do that. Okay. Now let me erase this. So what will happen? Now I will now I will write here this two inputs. I have two inputs now. And I have one output. So now what the neural network will do? Now the neural network, there is a connection from this to this. Okay. How can I connect? I can connect this way. What I will do is I will use this. So I will connect this to, I will connect this to. Not only that, even I could have done this one this way. Okay. No problem. It doesn't matter how we do, right? Ultimately, we have to do it. So this is our final one. There will be a bias here. Don't search a bias here. Okay. These are connections. That means some weightage will be given to this, some weightage will be given to this according to this data. That pattern we are trying to learn here. The pattern we are trying to learn here. Okay. Now what will happen is, suppose this one is 1050, right? 1050, 55. So what we'll do is, we'll see if we multiply some number to 10, okay? We see if we multiply some number to 10 and some number to 50, if we multiply some number to 10, okay? Doesn't look good. If we multiply some number to 10, if we multiply some number to 50, if we multiply some number to 50, if we add some number, this is the one here. Are we getting 55? This is training a neural network. Okay. So now mathematically, if you are doing, we'll multiply a number to 10, we'll multiply a number to 50, we'll add a number. Am I getting 55? Am I getting 55? Suppose I want to get 55, right? I'll take 50% of this. Okay. 50% of this means it's 5 by 10. 5 by 10 means this is 25 I'm getting here. Another 25 I have to get, okay, here. So another 25 means 2.5. This is 2.5. 25 here I got. Here I got 25, 50, and 5 here. So 5 here I can write. Exactly I matched, okay. So I should feel happy or I should not feel happy. I'm not happy. I'm not happy just because this works only one row data. This works only for one row data. We want our neural network to work for the whole data set. Okay. Now we have another one. We'll try for 20. We'll try for 30. We'll try for 40. Whatever numbers I've taken here, if I write the same number here, remember this is class 1. If I write the same number here, if I add the same number, am I getting 52? Am I getting 52? Because here we can't change these two. We can't change these two. So if I write 2.5 here, if I write 2.5 here, if I multiply with 0.5, if I multiply with 0.5, if I add with 5, am I getting 45 and 88? Am I really getting this? If I am getting all these, then awesome. Of course, because we'll have a lot of data, what will happen is you will never get exactly the values. Suppose these are the two students, Goyadhar and Hariharan. What we'll do is, this guy comes with finally 2 weights and 1 bias. You see, this is also a bias, this one. Okay, 2 weight and 1 bias. And this guy comes with 2 other weights and 1 bias. Okay, so which one I will accept? I will find the loss mathematically. That loss also will study, remember? So loss function is very important. In any optimization task, we try to minimize loss or we try to maximize gain. Okay, so here we'll try to minimize our loss. So I will check loss for, suppose loss for this guy is 0.02 and loss for this guy is 0.05. I will take these weights and biases. Nobody can come with loss 0, because exactly mathematically you will not get. Even if you can get mathematically, we have interpolation. Okay, there we try. You can get like for 3, 4, 5 for many numbers also. That won't be useful. There is a concept of overfitting. I mean, I don't want to take you to the mountain now. Okay, just learn in installments. Because steady, if you're steady, you will win the race for sure. Okay. Consistency is required. Now, but I mean, these numbers will not work, right? So, what ultimately I want to say is, suppose you get three numbers, okay? Three numbers. Now, how can you get those three numbers? We can try many ways, okay? There are iteration methods, there are mathematics also. I mean, the derivation, everything, they were there. But why deep learning became famous around 2000, starting from 2013, 14? There are so many reasons. Again, I'm not going to that. It's due to partly also NVIDIA, okay? Computing power, lot of data. What we have done by now, we must have found by now these, okay? Because we have not answered this guy. We'll answer here, okay? We'll answer this guy, the final mark. And the final mark here will be this one. How we'll get this one? We'll input here. 25 and 75, we'll see the output, okay? So to see this output will depend on these inputs. All right. So what will happen is, I will write 25 here. I will write 75 here. And I want to get here. I mean, not I want to get. Whatever I will get, I have to accept. And this will be our prediction. Okay. This will be our prediction. So to get this number, this output, this is my output, suppose y, and if this is x1, and if this is x2, my y is equal to a plus, a is this one, b1 x1 plus b2 x2. That means whatever a I will get here, whatever b1 I will get here, whatever b2 I will get here, I will put everything here and I will get the answer. Okay. So what I will do is, I will put a here, b1 here, b2 here, and I want the answer. Okay. So I will put 25 here. I will a. Suppose randomly I've taken 5 that point of time. Here I don't remember 2.5. Here probably I took 0.5, whatever. Okay. Because I know this, now I can multiply. A is 5 and B1 I've taken 2.5. I tested only for one row. Remember, not all, for all rows. Okay. So for all rows means we'll go to coding and we'll see what is the real one. We'll do it today if you're patient. Okay. So this is 5 and B1 is 2.5 multiplied by x1 is the input 25 plus b2 is 0.5 and x2 is 75. Boom! I got the answer. Awesome. So I'm so happy. I got the answer. Done. Ultimately, this is what you will learn. And people, there are two types. Those people who know, who don't know, right? But this much only. I mean, this only will go step by step, and a day will come where you will be a machine learning engineer, deep learning engineer. That's all. It's so easy, right? If you understand this much, you will be able to understand everything. Okay? All right, let's continue. Now we got it, and we have one output, two input, right? So now you can extend this one to many. What we can do is, suppose I have like this many. I have one input, I have two input, I have three input, I have four input, I have five input, and I want to get an output. So what will happen? I will try to connect this one with this one, this one with this one, this one with this one. I'm talking about neuron. There is a concept of perceptron. I'll go to that later. Okay. That's a historical one. Okay.